So in previous videos, we've looked at standard error of the mean. We've looked at confidence interval for a mean. This guy over here, we were looking at the videos 24 to 28 for confidence interval before going on to this one. So this is the margin error for a population mean. Now, it's a totally different formula here. We have to identify in this question that we're dealing with a proportional type thing. And this formula here is what we're looking at. The square root of p times 1 minus p over n is the standard error of the proportion. And if we look at a question, it might help this make sense. So in a survey of n voters, 0.7, so I've got p is equal to 0.7. Now you may see p hat and stuff. I'm just going to use p in these questions. 1 minus p is equal to 0.3. You'll identify that those two numbers always have to add up to 1. So that's always what's going to be in here on the top of the fraction. So a 95% confidence interval for this proportion, that's when we're thinking p, proportion, who said they voted was given by this guy here. So 0.7 said they voted, and we have this interval here. So I can see that between 0.7, 0.7284, 0.7284, the jump that we made, which is this formula, is going to give us the plus and minus standardizing formula for a proportion, separate to the previous one's confidence interval for a mean, then going back to the population itself. So we've added on 0.0284 here. So if we're asked to calculate n, we can say that 1.96 by the square root of 0.7 by p by 0.3 over n is equal to 0.0284. So I can do this in one step. I'm going to divide by 1.96, so 0.0284 divided by 1.96, that's going to be equal to the square root of this 0.7 by 0.3 over n. So maybe I'll just do it in log form. 0.7 by 0.3 is 0.21. So square on both sides. Do it like this. If I square both sides, that will get rid of the square root. And you can see that n will change places. So I have to divide by 0.0284 divided by 1.96 to be squared, and that will give me n. So n in this case is equal to, it's giving me nice and neat, nearly exactly 1000.47. So we are asked how many voters. I'm going to go for 1001 here. Round up the n, it was 1000.47. For the second part of this question, if the margin of error for a 90, the first one's 95, this one's 90, is given by this. Construct a 90% confidence interval for the proportion of voters who said they voted in the referendum. So we're just going to have 1.645 by the square root of, we've already multiplied 0.7 by 0.3, and we've worked out n around, well, I'll leave it at 1001. That's going to be our standardizing error. So let's see what this works out to be. No 0.0238, 0.238, we go 0.024. So that's what I have to add and subtract from my 0.7. So I'm going to get 0.724 at the high end. And on the lower end, I'm going to get 0.676. So that's a 90% confidence interval. Can't come up, it's on the course. It's mainly 95 that gets asked, but just be aware that it can be asked. And if the pollsters wanted to cut the margin of error in half, how many voters should be surveyed? Okay, and what do you notice? So they want to cut the margin of error in part 1 in half. So let's have a look at dividing it by 2 first. Okay, well, we should be able to just replace a number in this formula at the end here. So our margin of error was 284, 0.0284 in part 1. So just bring that down. So divide that by 2, 0.0142. Works out evenly enough. So you can see in this formula the point 0284 was on top. N was equal to the error 0.0142 divided by 1.96 to be squared will give me N. So N, if we cut the margin of error in half, is going to give me, and that's all on the bottom of 0.21. So N is going to give me 4000.87 or 4001. So we're asked, what do we notice? Well, what do we notice? We had N was equal to it. Let's round these off to 1000 and 4000 and we might see something. 1000 to 4000. So we halved the margin of error. So what is it? We have gone from 1000 to 4000. So we've halved the margin of error. So to halve the margin of error, we have to multiply sample size by 4.